Okay, good afternoon, ladies and gentlemen. This is Professor David J. De Los Reyes. For this afternoon, I will be discussing lesson number 14 on my analytic geometry topic. This is a long video format discussion. So, for those of you who are planning to take up engineering, this is for you guys. Okay, let's proceed. The subject matter is Analytic Geometry, lesson number 14. The title of the topic will be The Study of Parabola, Vertex at the Location HK. The last time around, I discussed the parabola, the 4 cases of parabola. Okay? But the difference from this one is actually the vertex from the previous lessons are actually at 0, 0, meaning the vertex is at the origin. But for this one here, the location of the vertex is actually at the location HK. I will place this one. This is the origin, so the coordinates will be 0, 0. This is the origin. Coordinate is 0, 0. This one, this is the origin. The coordinate is 0, 0. The first one here, this is the origin. Coordinate is 0, 0. So for this afternoon, we will be bringing out the concept of the study of a parabola in which the location of the vertex is not at the origin. This is the location of the vertex for the first case. Okay. Next to that, the location of the vertex is this one. It is not at 0, 0. For case number 2, there are 2 variations also, that is to the right and to the left. Okay. The vertex for the first one for case number 2 is this one here. It's not at 0, 0. The last one, since this is the origin, the vertex of the last one, the one that opens to the left, this is actually the vertex. So the only difference from the previous lessons is that the location of the vertices is actually the plural of vertex. It is at the location HK. Okay, there is a value for H and there is a value of K. Okay, and it is not 0. Because actually, if we try to bring out the equation of the previous lessons, okay, I will try to erase this one. If we try to bring out where the previous equations came out, the previous lessons, the one with the vertex at 0, 0, like this one here, I will place x minus h quantity square equal to, as an example, 4p times y minus k. From the previous lessons, the equations actually emanates from this. But luckily, the value of h is equal to 0 and the value of k equal to 0. So if this h and k are both 0, what will come out will be an x square equal to 4py. You remember this equation? This is the first equation of a parabola with vertex at 0, 0, meaning at the origin, okay, opening upwards. So it seems the equations for the parabolas with vertices at 0, 0, they actually emanates from this equation here. Okay? Okay, let's try to bring out the equation for case number 1. There are 2 cases. Okay, I will try to erase this one so it will look good. So we now know where the equation of a parabola with vertices at 0, 0 emanates. Where those equations came from. Okay? It actually emanates from the equation of a parabola with vertices at hk. So for case number 1, there are 2 variations. It's the same as from the previous lessons. The only difference is that the location of the vertices is actually at hk. Okay? This is at hk. That's the only difference. From the previous lessons, this hk is exactly at the origin. That's why I discussed the topics on parabola in 2 variations. Parabolas with vertices at 0, 0, meaning at the origin, and parabolas with vertices at hk. There are 4 variations there because for the vertical axis there will be the going up and the going down, and for the horizontal axis there will be the one that is going to the right and the one going to the left. So it's not hard to grasp the concept of lesson number 14. It's just the same as the concept of parabola with vertices at 0, 0. The only difference is that the location of the vertices is actually at hk. So there's nothing to explain over here. We just change the figure such that the location of the vertex will not fall at 0, 0. I will try to erase this one. This is 0, 0. It is at hk. So if we try to bring out the equation for the first case, there are actually 2 variations. The vertex is at the location hk, opening up or down. Axis is parallel to the y-axis. It's vertical. So I place it here, axis is parallel to y-axis. For the 2 variations under case number 1, this is going up, this is going down. The parallel of this one is vertical, and so with this one. That's why I place it here as a summary. Axis is parallel to y-axis. So for the equation, it will be this equation here. Okay? So the equation of this parabola, if the location of the vertex is at hk, is given by this equation here. For one value of y, okay, there will be 2 values of x, that is to the right and to the left. Okay? So, like what I said, the axis of this one is parallel to the y-axis. So the equation of this one is this. For the next variation, we will just reverse the figure. Instead of going up, it will be going down. And again, the location of the vertex is at hk. Regarding the equation, it will still be the same, but there is a negative sign here. Negative sign. This negative sign indicates that the parabola is actually opening downward. That's the significance of this negative sign. So the equation for this one, it is actually given by this. X minus h quantity here equal to, this is negative, 4p times the quantity y minus k. So this is actually the equation of option number 2 under case number 1. The one that opens downward. Okay. For case number 2, the location of the vertex is at hk, opening right or left, meaning to the right or to the left. Axis parallel to, the first one, it is parallel to the y-axis. But the second one, it is parallel to the x-axis. Like this one here. It just so happened that I drew the figure to fall under quadrant number 1. Okay. So this is the location of the vertex. The axis of the parabola is actually this line here. It is parallel to the x-axis, that's why I place it here. Axis is parallel to the x-axis. And if we try to bring out the equation of this one, it will be given by this equation here. That is y minus k quantity square equal to 4p times x minus h. For one value of x that we will be placing here, the sign of the right hand side will be positive. And since the left hand side is under the power 2, it will be a square root if we try to compute for the value of y. So for one value of x, there is a positive value of y and there is a negative value of y, up and down. But they should be plus. Okay. For the other one, it will still be the same. But for it to be a correct equation, because this one now opens to the left. If we try to bring out the equation, this will be the equation. But the difference of this one and to the second one is actually the negative sign. And the significance of this negative sign here, meaning is this is open to the left. Because if this is negative, for the right hand side to have a positive sign, the overall value of this quantity here should be a minus. So if we try to, if the overall sign of this one is negative, a negative will be positive. And since this is to the power 2, if we try to compute for the value of y, okay, it's a real value, there should be a plus and minus. So it's the same. There is an upward value, there is a downward value, but the only significance, it is going to the left. So the equation for option number 2 under case number 2 is y minus k quantity square equal to negative, there should be a negative sign here, times minus 4p times the quantity x minus h. So actually the equation of the first one and the second one under case number 2 are the same except for the sign. The one with the positive sign, it opens to the right, and the one with the negative sign, it opens to the left. Okay, that's it guys. That's the concept of a parabola with vertex at its k. Okay, actually a parabola with vertex at 0, 0 actually emanates from this. Right? It emanates from this. Because from the previous lesson, there is no h and there is no k. So if this h here is 0, we remove it. Then we remove this k here. What will come out? The equation is just x squared equal to 4py. That is the equation of a parabola with vertex at 0, 0 or at the origin, opening upward. So just think of it that if you try to bring out the equation of a parabola with vertex at 0, 0, it emanates from the equation of a parabola with vertex at its k. But with the given condition, h is 0, k is 0, if the location of the vertex is at 0, 0. 0, 0 meaning at the origin. Okay, that's it guys. I think I have given you already the concepts of the study of parabola and the different parameters that are involved in it. Regarding the parameters, it's not so much because what we only need here is the distance p here. The distance between the lateral recta is actually 4p. So this is 2p, 2p, and the distance from vertex to focus is p, and the distance from vertex to directrix, the fixed line, is also p. There's not so much of it. So the only problem here is to find the equation of a certain parabola, we must have to know the value of p for that certain parabola. Okay, good afternoon from Los Angeles. This is Professor David J. De Los Reyes. This is a discussion, long video format discussion of a parabola with vertex at HK. Either axis is parallel to the y-axis or axis parallel to the x-axis. Okay, good afternoon.